Welcome to Get Your FRQ On. This question is from 2008, Form B. It's question 5, and it is not calculator active. In the question stem, we're given a function g and known to be continuous. We're given that g of 2 is equal to 5, and the graph of the derivative of g prime is a piecewise function, and it consists of 4 line segments. The function g and its derivative are defined on the interval from -3 to 7. In part A of this question, we are asked to find the x-coordinates for all points of inflection of the graph of y equals g of x on the open interval from -3 to 7, and to provide justification. The graph of y equals g of x will have a point of inflection whenever the graph of g prime of x changes between increasing and decreasing. The graph of y equals g of x switches from increasing to decreasing at x equals 1. The graph of y equals g of x switches from decreasing to increasing at x equals 4. Therefore, we can conclude that the graph of y equals g of x has points of inflection at x equals 1 and at x equals 4. In part B of this question, we are asked to find the absolute maximum value of the function g on the closed interval from -3 to 7, and to provide justification. The graph of y equals g of x will have a maximum value either at x equals -3, x equals 7, or somewhere where g prime of x changes sign from positive to negative. Based on the provided graph of g prime of x, this happens only at x equals +2. To find g of -3, we take g of 2, add to that the integral from 2 to -3 of g prime of x dx. That's going to get me 5 minus the integral from -3 to 2 of g prime of x dx, which is 5 minus -4 plus 1.5, that's 7.5. G of 7 is g of 2 plus the integral from 2 to 7 of g prime of x. That turns out to be 1.5. And we're also given that g of 2 is 5 in the stem of the question. So now we have all 3 of those values. Comparing these 3 values, we conclude that the maximum value of g on the closed interval from -3 to 7 is 7.5. In part C of this question, we are asked to find the average rate of change of g of x on the closed interval from -3 to 7. The average rate of change of g of x on the closed interval from -3 to 7 is going to be g of 7 minus g of -3 over 7 minus -3, which turns out to be 1.5 minus 7.5 all over 10, and that gets me -6/10, or -0.6. In part D of this question, we are asked to find the average rate of change of g prime of x on the closed interval from -3 to 7. And then we are asked to determine if the mean value theorem guarantees some value of c, where g double prime of c is the average rate of change we just found. The average rate of change of g prime of x on the closed interval from -3 to 7 is g prime of 7 minus g prime of -3 all over 7 minus -3, which is 1 minus -4 all over 10, which is 5 over 10, or just 1/2. Checking limits. The limit as x approaches 1 from the left of g double prime of x is 0.5. The limit as x approaches 1 from the right of g double prime of x is -1. Now, since these limits are not equal, g prime of x is not differentiable on the entire open interval from 3 to 7. There's somewhere where it's not differentiable in that interval. So the mean value theorem cannot guarantee that there's some value of c in that interval where G double prime of C is equal to 0.5 anywhere. Maybe it's true, but the mean value theorem cannot guarantee it. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.